So we have to find the first 7 terms for the Taylor series at a equals 0 for the first function, and we also need to make a substitution in this Taylor series to get the first 7 terms of the second function. So the general term of Taylor series of a function f of x is f of x equals the sum of nth order derivative of f of a times x minus a to the power of n over n factorial, where n goes from 0 to infinity. So let's do some calculations in order to find the first 7 terms. So f of x in our case equals 1 over square root of 1 plus x. Then f of 0 equals 1. The f prime of x equals negative 1 over 2 times 1 plus x to the power of 3 over 2. And then f prime of 0 equals negative 1 over 2. The second order derivative of f of x equals 3 over 2 squared times 1 plus x to the power of 5 over 2. Then the second order derivative of f of 0 equals 3 over 4. The third order derivative of f of x equals negative 15 over 2 cubed times 1 plus x to the power of 7 over 2. Then the third order derivative of f of 0 equals negative 15 over 8. The fourth order derivative of f of x equals 105 over 2 to the fourth power times 1 plus x to the power of 9 over 2. Then the fourth order derivative of f of 0 equals 105 over 16. The fifth order derivative of f of x equals 945 over 2 to the fifth power times 1 plus x to the power of 11 over 2. Then the fifth order derivative of f of 0 equals negative 945 over 32. The sixth order derivative of f of x equals 10,395 over 2 to the sixth power times 1 plus x to the power of 13 over 2. Then the sixth order derivative of f of 0 equals 10,395 over 64. And the seventh order derivative of f of x equals negative 135,135 over 2 to the seventh power times 1 plus x to the power of 15 over 2. Then the seventh order derivative of f of 0 equals negative 135,135 over 128. Well, now the first 7 terms of Taylor's series for the function f of x at x equals 0 is f of x equals f of 0 plus f prime of 0 times x plus the second order derivative of f of 0 times x squared over 2 factorial plus the third order derivative of f of 0 times x cubed over 3 factorial, and so on. Then this equals f of 0 is 1 minus x over 2 plus 3 over 4 times x over 2 factorial plus 15 over 8 times x to, cubed over 3 factorial plus 105 over 16 times x to the 4th power over 4 factorial plus, minus, and here we had minus, my bad, minus 945 over 32 times x to the 5th power over 5 factorial plus 10,395 over 64 times x to the 6th power over 6 factorial and minus 135,135 over 128 times x to the 7th power over 7 factorial, and so on. So now to find the Taylor series for the function f of x equals 1 over the square root of 1 minus x, we substitute negative x for x, and here we get that f of x equals 1 plus x over 2 plus 3 over 4 times x squared over 2 factorial plus 15 over 8 times x cubed over 3 factorial plus 105 over 16 times x to the 4th power over 4 factorial plus 945 over 32 times x to the 5th power over 5 factorial plus 10,395 over 64 times x to the 6th power over 6 factorial plus 135,135 over 128 times x to the 7th power over